Hello, this is Leslie. We're going to be looking at Unit 2, Chapter 1, Function Transformations. And we're going to be looking at horizontal and vertical translations. And this is Part 1. We'll be doing Part 2 right after this one. Let's get started here. The focus on this particular lesson is determining the effect of h and k in the equation y subtract k equals the f of x subtract h has on the graph of y equals the f of x. And we're going to focus on sketching the graph of y subtract k equals the f of x subtract h for given values of h and k given the graph of y equals the f of x. Okay, let's get started. Horizontal and vertical translations. A vertical translation occurs when y is replaced with y subtract k in the function y equals the f of x. So if we're given a function y equals the f of x, if we replace y with y subtract k, it will result in a vertical translation of k units. This equation here, of course, can also be written, and I'm sure you've seen it written like this as well, as y equals the f of x plus k. Certainly another way to view the same equation. So either one of these would represent a vertical translation of k units. A horizontal translation occurs when x is replaced with x subtract h in the function y equals the f of x. So if you've got an equation y equals the f of x, and notice here the x is replaced with x minus h compared to your vertical translation where y is replaced with y minus k. So here we're replacing y with y subtract k, here replacing x with x subtract h. Again, the same result is that we'll end up now, of course, with a horizontal translation of h units. Let's take a look at a simple example here dealing with horizontal translations. Let's consider the function y equals the absolute value of x. Here's the graph of y equals the absolute value of x already constructed for us. And we're going to look at, of course, the graph of y equals the absolute value of x subtract 3. Note again that x is replaced with x subtract 3 will result in a horizontal translation of 3 units to the right. So if I'm going to sketch this graph, I simply need to take this graph and move it 3 units to the right. So let's do that. Moving it 3 units to the right, I'm going to take the vertex and move it 3 units to the right. And every other point will move exactly the same. And you'll notice that the slope of this line is -1. The slope of this line is +1. So I need to simply construct 2 lines here, one with a slope of -1, one with a slope of +1. And that would represent the graph of the function. So let's do that. I'm just sketching that graph for you. Right there. There's my slope with a -1, and here's my slope with a +1. And there's the graph of the new translated function. And you can clearly see that the graph has been translated 3 units to the right. Let's look at the domain, the range, and the mapping rule for this new function. The domain is the values of x that you can find points on the graph. It's always the way I interpret domain and range. Domain, values of x that I can find points on the graph. I can find points on this graph for every possible value of x. No matter what value of x I choose, I can find a point on this graph. So my domain is simply going to be x such that x is an element of the real numbers. The range, of course, is the values of y that you can find points on the graph. So if I look at the graph here again, the values of y that I can find points on this graph is simply values of y greater than or equal to 0. I cannot find a point on the graph when y is -1 or -2 or -3, but rather 0, 1, 2, 3, 4, and so on, I can find points on the graph. So my range is simply going to be y such that y is greater than or equal to 0, where y is an element of R. Now you should have learned as well how to create a mapping rule for this function. The mapping rule is simply going to be xy maps to x plus 3 comma y. X plus 3 comma y represents a horizontal translation of 3 units to the right. I normally get my mapping rule from the equation. I always take the opposite of what I see in here, and that's what goes in my mapping rule. X plus 3 because I see an x minus 3 here. But again, it represents a horizontal translation of 3 units to the right. Let's have a look at another horizontal translation. Let's consider y equals the absolute value of x plus 4. You can see now, compare it to the base function, y equals the absolute value of x. The graph will now end up with a horizontal translation of 4 units to the left. X is replaced with x plus 4 will result in a horizontal translation of 4 units to the left. So I simply do the exact same thing. I sketch a graph by moving the base function 4 units to the left. Let me do that. Simply move my graph 4 units to the left. And here's what my graph will look like. Something like that. There we go. So there's the graph. Move 4 units to the left. So this graph here is y equals the absolute value of x. Subtract 3. The last graph that I drew was y equals the absolute value of x plus 4. Horizontal translation of 4 units to the left. In the same way, we can easily find the domain, the range, and the mapping rule again. The domain, again, is the values of x that you can find points on the graph. Again, that will not change. It's simply going to be x such that x is the number of the real numbers. I can find points on this graph for all possible values of x. And the range, again, no change here, is simply going to be y such that y is greater than or equal to 0, where y is the number of var. The mapping rule, on the other hand, does change. The mapping rule is going to become x subtract 4, comma, y. Again, if you look at the x plus 4 here, you take the opposite, it becomes x subtract 4, representing a horizontal translation of 4 units to the left. So there's a couple of very quick and simple examples that involve horizontal translations. Let's now have a look at some vertical translations. Again, let's consider a new function. Let's consider the function y equals x squared. Y equals x squared is, as of course you know, it's a parabola that opens upwards. Y equals x squared, the graph is already drawn for us here. Let me simply label that. Now we're looking at vertical translation, as I've said. So y is replaced with y subtract 4. So y is replaced with y subtract 4 will result in a vertical translation of positive 4. Again, you will oftentimes see this equation written as x squared plus 4. Again, a vertical translation of positive 4. Or, thinking of it this way, y subtract 4, vertical translation of positive 4. Let's sketch the graph. All we need to do is take the graph that we have produced, and we're going to take that graph and we're going to move it vertically 4 units up. So let's take some points on the graph. Here's my vertex, move 4 units up. Let's take a couple of other points on the graph and move them up vertically. I just labeled the points -1, 1. Let's move it up 4 units. Right there. And let's move the point 1, 1 up 4 units. That will be located right here, of course, at 1, 5. And I guess I could take a couple of other points here. -2, 4 is a point on the graph. Let's move that up 4 units. 1, 2, 3, 4. And 2, 4 is a point on the graph. So let's move that point 2, 4 up 4 units. 1, 2, 3, 4. And all I need to do is join them up, and I'll have the sketch of my graph. So let me proceed to do that as best I can here. And there's the graph of y equals x squared plus 4. Again, a vertical translation of 4 units up. Domain of this graph hasn't changed. The domain is still all real numbers. The range of this graph compared to the graph of y equals x squared has changed. It now becomes y such that y is greater than or equal to 4, where y is the number of r. Again, 4 because it's the values of y that I can find points on the graph. I can find points on this graph for all values of y greater than or equal to 4. Cannot find a point on the graph when y is 3 or 2 or 1 or 0 and so on. Only for values of y greater than or equal to 4. There's my range. The mapping rule looks like this. XY maps to. There is no horizontal translation, but there is a vertical translation, and it's y plus 4. Vertical translation of 4 units looks like y plus 4 in the equation. Again, I normally look at it and take the opposite of the equation from here. Y subtract 4 because of y plus 4. Or, if you want to think about it as an equation written in this form, it's the same as what you see there. You just need to create what you're most comfortable with, whether you use this form of the equation or this form of the equation. It's entirely up to you. Considering the same graph, y equals x squared, now you see that I've got x squared subtract 1, or another way of writing that, of course, is y plus 1 equals x squared. Again, two ways to write the equation. You can write it in this form or in this form. This is actually called transformational form. This is called functional form. But both represent the exact same thing. Both represent a vertical translation of -1. So now I need to do the exact same thing. I simply need to take the graph and move it down 1 unit. I'll do that very quickly. Take the graph and move it down 1 unit. Let's plot some points here. Moving it down 1 unit. We'll be right there and right there. Okay, let's join those up as best that I can here again. Not a great graph, but you get the idea. There's the graph of the function y equals x squared moved down 1 unit. Domain, still all real numbers. The range of this graph, I'm sure you'll agree, is greater than or equal to -1. And the mapping rule becomes xy maps to x, comma, y subtract 1. Y subtract 1. So there's a quick review of vertical translations. Let's have a look at another example here. Notice this, this example has both translations occurring in it. I'm asked to sketch the graph of y equals the absolute value of x subtract 4 plus 3. Okay, we need to look at this and determine what type of transformations are occurring first of all. Let's get the mapping rule, the domain and range, and let's sketch this graph. So, of course, the base function, again, is y equals the absolute value of x. I've taken the base function, and we've done this to it. The x minus 4 will result in a horizontal translation of positive 4. And, of course, the plus 3, choose a different color here, the plus 3 will represent a vertical translation of positive 3. Vertical translation of positive 3. So this graph, y equals the absolute value of x, is moved horizontally 4 units to the right and 3 units up. So I go 4 units to the right. Think of it taking this point, 4 units to the right and 3 units up. There's my new vertex is going to be located right there. And again, the slopes of the two lines haven't changed. They're still 1 and -1. So all I need to do is simply create two lines with slopes of 1 and -1. There's your slope of -1. Here's your slope of 1. There's my new graph sketched. The graph of my new function. The mapping rule, of course, will look like this. xy maps to. We have a horizontal translation of 4 units, so it becomes x plus 4. And the vertical translation of 3 units becomes y plus 3. Again, if you want to think about the equation in transformational form, it would have looked like this. Y subtract 3 equals the absolute value of x subtract 4. Some students, I'm sure, learned the view the equation in this form. Some students probably learned the view the equation in this form. So I want to cover both forms here. This is called transformational form. This is called functional form. Either one of these will result in the same mapping rule, of course. Domain and range, pretty simple here. The domain, again, is all real numbers. Oops, let me fix that. The domain is x such that x is a number of real numbers. And the range is y such that y. Again, ask yourself the question, for what values of y can I find points on the graph? I can find points on this graph for all values of y greater than or equal to 3, where y is known with r. And there's a quick example that involved both horizontal and vertical translations. Let's move on. Let's have a look at another example. Notice this function is not a function like the two we've already looked at. It's not a parabola. It's not an absolute value graph. It's just a function with a set of points. So the function is simply y equals the f of x. Again, if you notice, we've done two transformations to the function. Let's list the transformations first. The x subtract 2 will result in a horizontal translation of positive 2, and the negative 4, or the subtract 4, results in a vertical translation of negative 4. Vertical translation of negative 4, horizontal translation of positive 2. Again, if you want to put it in functional form, I could write it like that: y plus 4 equals the f of x subtract 2. Mapping over this function becomes xy maps to x plus 2, y subtract 4. And again, you can get that, this has been taught in many different ways. Some students get it directly from here. Some get it from this equation. Some get it from this equation. I normally get it from this equation. I take the opposite of everything. The x subtract 2 becomes x plus 2. The y plus 4 becomes a y subtract 4. Or you can look at it from here and say I take the opposite of what you see here. X minus 2 becomes x plus 2 in the equation. But the minus 4 here remains as it is, y subtract 4. Okay, let's move our graph. Let's do exactly what we said we would do, and let's take all the points and let's move them horizontally 2 units to the right and 4 units down. So let's take every point and move them 2 units to the right and 4 units down. So there's A prime. A prime represents the new coordinate for A after the transformations have occurred. B prime, we go 2 units to the right again, and we go 4 units down. There's B prime. C prime, 2 units to the right, 4 units down. C prime right here. D prime, 2 units to the right, 4 units down. There's D prime. And finally, E prime, 2 units to the right and 4 units down. And there, of course, is E prime. All we need to do is join them up the exact same way they're joined up in the original function. So A is joined to B, so we join A prime to B prime. We join B prime to C prime, C prime to D prime, and finally D prime to E prime. And there's my translated graph. And you can see that this graph is exactly what we said. We've moved the graph horizontally 2 units to the right and 4 units down. Let's do the remainder range again. The domain of the graph is the values of x that you can find points on the graph. Let's look at the translated graph. I can find points on this graph for values of x between negative 4 and positive 5. Between negative 4 and positive 5. So I write x such that x is between, that's how I write between, negative 4 and positive 5, including negative 4 and including negative 5. So that's why the equal to signs are there, where x is an element of the real numbers. The range, of course, becomes, we need to consider simply the values of y that I can find points on the graph. I can find points on this graph for values of y between negative 2 and 0. That's it. I can't find points on the graph outside of these two values, between negative 2 and 0. So I write y such that y is between negative 2 and 0, where y is an element of R. Just remember, when you're representing between two numbers, you always put the lower number on this side of the less than sign. So if you're going to use less than signs, which I suggest you do, lower number here, higher number here. Same with your domain. Lower number of negative 4, higher number of 5. There's your domain and range. Let's have a look at a couple of examples here that involve multiple choice, which is probably what you're going to see on a public exam, is a multiple choice from this section. Which equation results when the y equals the f of x is transformed using this mapping rule? We got y subtract 7, comma y plus 1. You should know now that that's a horizontal translation of negative 7, a vertical translation of positive 1. You may want to pause the recording for these multiple choice questions and try it yourself before you continue the recording. But I will continue. Again, you may want to pause it and try it yourself first. The correct answer to this one is, let me look for it here, it's going to be y equals the f of x plus 7 plus 1. That's the correct answer there. Again, think about the fact that if I were to write this in transformational form, I always take the opposite of what I see. And again, that's just the approach that I take. X plus 7 becomes x minus 7. Y subtract 1 becomes, y subtract 1 becomes y plus 1. Again, so you may have just learned to get it directly from this equation. That's fine. The f of x plus 7, x minus 7, y plus 1. Okay, let's have a look at another multiple choice question dealing with this topic. Which transformations occur when the vertex of the parabola y equals x plus 1 squared subtract 5 is mapped to 4 and negative 7? Now, the first thing we need to do is be able to identify the vertex of this parabola. You should recognize this as a parabola with a vertex at negative 1 and negative 5. So negative 1 and negative 5 is the vertex of my parabola, and this vertex has been mapped to 4, negative 7. So if you wish, we can do a very quick sketch here and think about what this looks like. I get a parabola with a vertex at negative 1, negative 5, negative 1, negative 5 right here, and it's been moved to 4, negative 7. So it's been moved here, 1, 2, 3, 4, and negative 7. So down 2 more units. So we just need to think about what transformations occurred to get the vertex of this parabola, and there's a parabola that opens upwards, over here. That's all we're really thinking about. And all we need to do is simply count. The graph has been moved 5 units to the right. 5 units to the right has gone from negative 1 to positive 4. So that's a horizontal translation of 5 units right. And the graph has moved 2 units down, a vertical translation of negative 2. So again, we're looking for which of the 4 answers you see are correct. Horizontal translation of 5 units to the right and a vertical translation of 2 units down. The correct answer is D. Again, you just need to think about this point. It's moved 5 units in that direction from negative 1 to positive 4. And it's been moved down 2 units because we started at negative 5 and we moved it down to negative 7. Let's have a look at one more example here. The point AB is on the graph of the function y equals the f of x. What are the coordinates of the image point on the graph of y plus b equals the f of x plus 1? Again, it might be a good idea to pause the recording and try this example first. Okay, let's continue. The point AB is on the graph. What will the coordinates of the image point be? What I'm simply going to do here is create a mapping rule for this function. My mapping rule is xy maps to x subtract 1, y subtract b. X subtract 1, y subtract b. The point AB will be translated to, the new image point AB will be translated to, let's replace x with a, and we'll have a subtract 1. Let's replace y with b, and we'll have b subtract b. And therefore the point AB will be mapped to a subtract 1 comma 0. The correct answer is C. So I simply created a mapping rule for that function, and I plugged in the point AB into the mapping rule to see where the new point A will be mapped onto. Okay. Let's do a quick summary of the key ideas in this lesson. Translations are transformations that shift all points in the graph of the function up, down, left, or right. And of course, in this particular lesson, we looked at simply looking at, well, we did look at horizontal and vertical translations. And again, we didn't change the shape of the graph at all. The table summarizes translations. Again, y minus k or y equals the f of x plus k, doesn't matter how you see that, represents a vertical translation of k units. Here's what the mapping rule looks like. Again, if k is positive, is a translation up. If k is negative, is a translation down. And again, if you look at a quick example here, here's the original function, moved up k units or moved down k units, if k is less than 0. Same is true with the horizontal translation. Here's the base function, y equals the f of x, here's the function y equals the f of x subtract h. We got a horizontal translation of h units. If h is greater than 0, it's a translation to the right. If h is less than 0, it's a translation to the left. Here's what your mapping rule looks like. Again, we take the graph and move it either left or right. A sketch of the graph of y subtract k equals the f of x subtract h, or the f of x subtract h plus k, can be created by translating key points in the graph of the base function, y equals the f of x. So there again is a summary of the key ideas for this lesson. And that ends this particular lesson.